Good morning to all. Today we are going to say electrical properties of metals. First we'll see the introduction. Solid state materials are classified into conductors, semiconductors and insulators based on the electrical conductivity. Electrical conductivity is due to the motion of free electrons. Heating and illumination in domestic and industrial applications are due to the property of electrical energy. Free electron theory of solids. This theory explains the structure and properties of solids through the electronic charges. It is used to understand the behavior of conductors, semiconductors, and insulators. It is also used to understand the electrical, thermal, and magnetic properties of solids. Free electron theory is subdivided into classical free electron theory, quantum free electron theory, zone theory, or band theory. Now we'll see one by one. First, classical free electron theory. This theory was proposed by Drude and Lawrence in the year 1900, where free electrons are responsible for electrical conduction in a metal at constant potential. Quantum free electron theory was proposed by Sommerfeld in the year 1928, where the electrons in a metal move a constant potential. Zone theory or band theory. This was proposed in the year 1928 by Bloch, where the free electrons move in a periodic potential. Postulates of classical free electron theory. In this theory, metal consists of very large number of free electrons that are moved freely in the metal. Free electrons move randomly in all possible directions. In the absence of electrical field, the electrons move in all direction in a random manner. But in the presence of electrical field, electrons begins to move towards the positive potential, which is shown in the figure. Velocity and energy distribution of free electrons are governed by classical Maxwell distribution function. The electrons are assumed to be a perfect gas. They obey the laws of kinetic theory of gases. Now we'll see quantum free electron theory. This theory is the evolution of failure of classical free electron theory. It was introduced by Sommerfeld in the year 1928. What are the postulates of quantum free electron theory? In a metal, the available free electrons are fully responsible for electrical conduction. The electrons move in a constant potential inside the metal. They cannot come out from the metal surface, which have very high potential barrier. Electrons have wave nature. The velocity and energy distribution of electron is given by Fermi-Dirac distribution function. The loss of energy due to interaction of the free electron with the other free electron. Electron distributed in various energy levels according to Pauli's exclusion principle. Now we'll see the advantages and drawbacks of quantum free electron theory. This theory explains a specific heat capacity of metals, photoelectric effect, Compton effect, black body radiation. And also this theory gives the correct mathematical expression for the thermal conductivity of metals. Drawbacks are this theory fails to distinguish between metal, semiconductor and insulator. It also fails to explain the positive value of Hall coefficient. According to this theory, only two electrons are present in the Fermi level and they are responsible for conduction, which is not true. Now we'll see the band theory or Bloch theory. The postulates of band theory are free electrons move inside periodic lattice field. According to band theory, potential energy of an electron within the crystal is periodic due to the periodicity of the crystal. The potential energy of the solid varies periodically with the periodicity of space lattice A, which is interatomic distance spacing. Inside a crystal, the electrons move through a periodic arrangement of positively charged holes. From this band theory or Bloch theory, we have a theorem called Bloch theorem. In this Bloch theorem states The solutions to Schrodinger's equation in a periodic potential take the form of a plane wave modulated by a periodic function. Functions of this are known as Bloch functions or Bloch states and serve as a suitable basis for all the functions or states of electrons in a crystalline solids. For example, describing electrons in a crystal, especially in characterizing the crystal electronic properties such as electronic band structure. But Bloch wave description applies more generally to any wave-like phenomenon in a periodic medium. A periodic dielectric structure in an electromagnetic leads to Phonon crystals, and a periodic acoustic medium leads to a phononic crystal. These are the examples for Bloch theorem. Thank you.